complex conjugates. In previous exercise 2.3, we have gone through associative property of addition, associative property of multiplication, distributive property, multiplicative over addition, and finding additive and multiplicative inverse of few complex numbers. We have studied some properties of complex numbers also, that is closure property in addition and multiplication, commutative property in addition and multiplication, associative property in addition and multiplication, additive identity and multiplicative identity, additive inverse and multiplicative inverse, and the property to proof of commutative property under addition and inverse property of under multiplication. Now we are entering towards a new exercise called conjugate of a complex number, that is complex conjugate of a complex number. So in this we are going to see properties of complex number. Before seeing properties of complex numbers, we are going to study what is my conjugate. Then only we are going to move inside the properties of complex conjugates. What is mean by conjugate? The conjugate we have studied. For example, 1 divided by 1 plus I, we will do the conjugate nothing but 1 minus I divided by 1 minus I. This also we can call as a conjugate. For example, 1 divided by 1 plus I. The complex number should not present in denominator, so we need to multiply the complex conjugate 1. This plus I will connect to minus I and minus I. This is also we called as conjugate. So another conjugate is nothing but a bar. For example, Z is equal to x plus iy. Z is equal to x plus iy. This is one of the complex number. Taking conjugate on both sides. The conjugate, for example, taking conjugate on both sides. Taking conjugate on both is nothing but z bar. This is called conjugate. Conjugate is meaning bar. Z bar is equal to x plus iy the whole bar. Taking bar on both sides. This is called conjugate. This is also another conjugate. Z bar is equal to x plus iy the whole bar. This bar, to remove this bar, that is remove the conjugate nothing but x. This plus I we need to make it as minus iy. Suppose if this minus is present, I need to put plus. Yes, x plus iy is nothing but x minus iy. The same conjugate. 1 plus I, 1 plus a conjugate is 1 minus I. X plus iy, the bar, conjugate is, you can say it is a bar or you can say the conjugate. X plus iy conjugate or x plus iy bar is equal to x minus iy. So conjugate of x plus iy is nothing but x minus iy. Yes, x minus iy. So this is the nothing but conjugate. For example, if we are going to take some few examples, I am going to give you a few more examples. 1 plus I. If we are going to take z1 is equal to 1 plus I. What is conjugate? z1 bar is equal to 1 plus I bar. 1 plus I bar is nothing but I need to remove 1 bar, so I want to put 1 minus I. To remove the bar, this plus I need to change to minus. 1 is the I only need to change, only, listen very carefully, only I need to see the symbol of imaginary. If plus I need to write as minus I. So conjugate of 1 plus I is nothing but 1 minus I. Listen carefully. Conjugate of 1 plus I is 1 minus I. So I am going to give you a few more examples. Z2 is equal to 4 plus 3I. Z2 is equal to 4 plus 3. Conjugate of Z2 bar. Conjugate of Z2 bar. Conjugate of Z2 is nothing but Z2 bar. Conjugate of 4 plus 3 is nothing but 4 minus 3I. I can write direct answer. You don't need to put bar and don't need to write answer. You can write direct answer. Z2, conjugate of Z2 is nothing but Z2 bar. 4 plus 3I is nothing but 4 minus 3. This plus I need to change the minus I. In this I need to say one important thing. Conjugate always occur in pair. Complex conjugate always occur in pair. Listen carefully. Complex conjugate always occur in pair. See, 1 plus I. Where is 1 plus I conjugate is 1 minus I. 4 plus 3I conjugate is 4 minus 3I. X plus iy conjugate is x minus y. Occurs in only on pair. Conjugate, always complex conjugate occurs only on pair. So this is the main thing you need to learn. So you have learned what is my conjugate. I am going to give few more examples. For example, Z3. Z3 is equal to 4. Whether 4 is a complex number? Yes, 4 is also a complex number, because this 4 I can write as 4 plus 0i. 4 is real number also, 4 is complex number also. For 4 we can write as 4 plus 0i. We saw in few examples also in previous introduction. Therefore, conjugate Z3 bar is equal to 4. I need to write as it is, because for any real number, if you are going to do the conjugate, the answer is going to be same. Z3 conjugate is Z3 bar. 4 conjugate is 4. Why? We are going to change only the real number symbol only. Plus I means minus I. Plus 3i means minus 3i. There is no imaginary at all. So I can't change the symbol. So 4 means as a 4. So you need to learn this important thing, very very important. If there is only real number is present. If there is only real number is present. See here, Z3 is also 4. Its conjugate Z3 is also a 4. Therefore, Z3 is equal to Z3 bar for when only real. When Z3 is only real, Z3 is equal to Z3 bar. For example, if I go and take Z is equal to 10, what will be Z bar? Z bar is also 10. That's all. Because there is no imaginary. For example, Z is equal to 10 plus I. What will be Z bar? 10 minus I. Because the plus sign change to minus. Here Z and Z bar are both are not equal. Here both are equal. When Z is real, Z bar is also real only. When Z is real, Z bar is real only. Therefore, Z is equal to Z bar. You can say when Z is real, if Z is real, Z is equal to Z bar. If Z is equal to Z bar, therefore Z is real. You can say backward also. So only we use if and only if. I will say afterwards this condition, very important one. If you want to listen, I will tell you now itself, no problem. For example, Z is equal to 5. What will be Z bar? Z bar is also a 5. For what? How can I write? If Z, this is only real, no imaginary. If Z is real, Z is equal to Z bar. Z is equal to Z bar. If Z is real, Z is equal to Z bar. Yes, both are 5 only answer. We will use if Z is equal to Z bar. If I say Z is equal to Z bar, then Z is real. You can say this also. When Z equal to Z bar, suppose Z is equal to Z bar, then I can say Z is real. If and only if. That is, we can say Z is real, Z equal to Z bar. Z is equal to Z bar, then you can say Z is real. You can use so only in one word we will say Z is real if and only if. If and only if Z is equal to Z bar. In spite of writing 2 lines, we can write in 1 line using if and only if. If and only if. Otherwise I can use IFF. If and only if, otherwise I can use IFF. Okay, so these are the main thing you need to learn. Another thing I told is nothing but 10 is also a complex number. 10 plus I is also a complex number. 10 I can write as how can 10 can be a 10 plus 0 I know. This is also a complex number. For example, Z is equal to 5I. What will be Z bar? Z bar is something but this is plus I know. I need to write minus 5I. Now only we have saw if Z is 5, Z bar is equal to 5. Therefore, if Z is real, if and only if Z is equal to Z bar. Z is equal to Z bar. Both are 5. Now I am going to take, this is only real. Now I take purely imaginary. I take only purely imaginary. Z is equal to 5I. What is Z bar? This plus side will convert to minus 5I. Right as it is. After this line, Z bar, minus. What is 5I? 5I is nothing but Z. So what you found? Z bar is equal to minus Z. So how I can write? Z is imaginary. This is imaginary, no. Z is purely imaginary if and only if Z bar is equal to minus Z. Z bar is equal to minus Z. I can give you one more example also. So Z is equal to 10I. What will be Z bar? Plus 10I, no. So I can minus 10I. So z bar, write z bar as it is, minus, write minus as it. What is 10i? 10i is nothing but z. So put. So z bar is equal to minus z. When z bar is equal to minus z? When z is purely imaginary. When z is purely imaginary, we can say z bar is equal to minus z. When z bar is equal to minus z, we can say z is purely imaginary. This is one of the property only, but I teach you now itself. I taught you now itself. So this is very, very important one. So now I am going to represent graphical representation. For example, this is, this is one of the graph. One graph is nothing but this is real line. This is imaginary number, imaginary line, real line, imaginary line. Suppose if I going to take one z here, one line z here, this is one of the z. If I going to take one of the z here, how this, if it is z is equal to x plus iy means z is equal to, because it can be x, it can be y. I have told you previous itself, you can write I, 2i, 3i, otherwise you can write 1, 2, 3 in imaginary. In most of the textbook they will write 1, 2, 3, but this is imaginary. You need to put I. This is x distance, this is y distance. Its reflection will be, what will reflection? Nothing but conjugate, nothing but x minus iy. This is x plus iy. Z, it will be a z bar. Z bar is nothing but x minus iy. This will be a minus y, minus iy. So in spite of giving this, I will give you example in numbers. See the numbers. For example, if I am going to take z as 4 plus 3a, what is conjugate z bar? Nothing but 4 minus 3a. So I give in graphical representation. So this will be real line, this will be imaginary, this will be minus real, this will be minus imaginary. So I can write 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2 and minus 3. So z is equal to 4 plus 3, its conjugate z bar is equal to 4 minus 3a. So first I am going to represent 4 plus 3a. 4 is real, 3 is imaginary. This is imaginary, no, 3. So nothing but z. This is z. Therefore z is equal to 4 plus 3i. So this is, I need to mark. This is a line. This is an origin, this is a ending line. Therefore this will be a z. Z is equal to 4 plus 3i. So what will be z bar? 4 minus 3. 4 is present here, minus 3. 4 is real, minus 3 is imaginary. 4 is real, minus real. So this is, what is this? Z bar. Z bar is equal to 4 minus 3i. So I need to join this. 4 minus 3i. Z bar is equal to 4 minus 3. So reflection of z is nothing but z bar. Reflection of z is nothing but z bar. So this is geometrical representation of a conjugate of a complex number. So complex numbers always occurs in conjugate pair. They occurs in pair. Conjugate. Complex numbers always occurs in conjugate pair. So this is very, very important one. If z is equal to x plus iy, its conjugate is nothing but z conjugate is nothing but z bar. X plus iy conjugate is nothing but x minus iy. So another important thing I need to teach you. This will be very useful in our using the problems. You know the formula. A square minus b square, a plus b into a minus b. This is one of the algebraic expression. I will write once again. A plus b into a minus b, a plus b into a minus b is equal to a square minus b square. This is one of the algebraic expression. Suppose if I am going to take in a plus ib, this is one of complex number. A minus ib, the formula will be a square plus b square. Listen carefully. If it is only a real number, a plus b, a minus b, you can write a formula a square minus b square. If the a plus ib complex, a minus ib complex, this complex number. See here, a plus ib conjugate is nothing but a minus ib. What is conjugate of a plus ib? A minus ib. A plus ib conjugate is a minus ib. Then you can say a square plus b square. I will try to give some few examples. 3 plus 4i, 3 minus 4i. I can write 3 square. Only b alone I need to take. I should not take I. I should not take I, only b square. So b is nothing but 4. 4 square, 3 square plus 4 square. So this is very important one. This is very important one. Okay. Now we are entering towards the properties of complex conjugates. The first property is z1 plus z2, the whole bar we can write as z1 bar plus z2 bar. What is the meaning of this? Suppose z1, for example, z1 is equal to 4 plus 3i. If I going to take z2, z2 is equal to 3 plus 4i, 3 plus 4i. I am going to apply here. First take LHS and apply here, LHS. What is LHS here? z1 plus z2, the whole bar. First z1 plus z2, I need to add z1 and z2, then I need to put bar. What is z1 plus z2? You need to add real and real. 4 plus 3, 7 plus z, imaginary, 3 plus 4, 7i. 7i. So what is the bar? 7 plus 7i. So if I need to remove the bar, I need to, this plus I need to write as minus I. 7 minus 7i, that's all. This is LHS. Suppose if RHS, what is RHS? Z1 bar plus Z2 bar. So what is Z1 bar? Z1 is 4 plus 3i. What is bar? Bar is nothing but plus I need to change to minus. 4 minus 3i plus Z2 bar. What is Z2 bar? Z2 bar is nothing but Z2 bar is nothing but 3 minus 4i. 3 minus 4i. Check it answer. 4 plus 3, 7 minus 3i minus 4i, which gives us minus 7i. 7 minus 7i. Both are same answer, no? So you can write Z1 plus Z2 the whole bar. Z1 plus Z2 the whole bar. I can separate Z1 bar plus Z2 bar. This is the first property. So what is second property? Second property is Z1 minus Z2 the whole bar. We can write as Z1 bar minus Z2 bar. This is in the subtraction. So as I proved in addition, I don't need to want to prove in subtraction. If you want, you can prove and see in subtraction. So third one. What is the third one? Z1 into Z2 the whole bar. I can write as Z1 bar into Z2 bar. So this is in multiplication. First one is addition. Remove nothing but I am separating the conjugates. That is addition. Adding two complex numbers and it conjugates and addition. Conjugate of complex numbers and its addition. That's all. Only difference. So the fourth property is nothing but Z1 divided by Z2. Z1 divided by Z2. Now in division, no, whole bar. That is only one bar. I can write as Z1 bar divided by Z2 bar. The only condition is Z2 is not equal to 0. It should not be 0. If it is 0, then what will happen? It will become infinity. So this is only condition. So now only we saw the conjugates. That is conjugates for addition, subtraction, multiplication, division. As I proved only for addition alone. If you want, you can prove and see for all the four quantities. That is 4 operations: addition, subtraction, multiplication, division. So these are first property. This is second property. Third property, fourth property. Please learn all these 4 properties. So you should not have any doubt. No, you need to learn all the 4 properties. Next we are going to see the fifth property. Fifth property is nothing but real part of z is equal to z plus z bar by 2. Real part of z is nothing but z bar by 2. Next I will write the sixth property also. Imaginary part of z. Imaginary part of z is not equal to z minus z bar divided by 2i. Sorry students, this is z. Z plus z bar by 2. I will write once again. I will write fully erase z plus z bar divided by 2. Z minus z bar divided by 2i. 2i. So how we can prove this? Very easy. This we have proof in our exercise sum also, but I will prove now itself. The real part of z is equal to z plus z bar by 2. Imaginary part of z is equal to z minus z bar divided by 2i. For example, we are going to consider z is equal to x plus iy. What will be z bar? X minus iy. That's all. Let let z is equal to x plus ay. Z bar, z conjugate is z bar, x plus a conjugate is x minus a plus I mean minus ay. So first I will add z plus z bar, z plus z bar, z plus z bar, x plus x, 2x, plus iy minus iy cancel. So bring down 2 here, z plus z bar divided by 2, let x also remains. So what is x? Check it. What is x? X is nothing but real part of z. So z plus z bar divided by 2 is nothing but real part of z. What is the real part of z? What is the real part of z? Nothing but x. What is imaginary part of z? Nothing but y. The real part of z is nothing but z plus z bar by 2. Suppose the same one. Let z is equal to x plus ay. What is conjugate? Z bar is equal to x minus ay. Now subtract. This plus will change to minus. This plus will change to minus. This minus we need to change to plus. Here I am adding, here subtraction. Z minus z bar. Z minus z bar. Plus x minus x cancel. Iy plus iy. Nothing but 2iy. So let 2iy comes down. Z minus z bar divided by 2y is equal to y. 2y is equal to y. What is y? Y is nothing but real part of z. What is y? Sorry, imaginary part of z. Imaginary part of z is nothing but y. Y is nothing but imaginary part of z. So z minus z bar divided by 2y. So this is our property 5 and property 6. So property number 7. What is property number 7? Z power n, the whole bar, we can write as z bar whole power n. Nothing but I am moving bar inside, n outside. That's all. Where n is integer. N is an integer. It should not be a fraction. It should not be a fraction. It should not be a decimal. Okay. Next, 8th property is well-known property. Z is real if and only if z is equal to z bar 9 to 1. Z is imaginary if and only if z is equal to minus z bar. In spite of writing this type, we will put r. Z bar is equal to minus z. Z bar. Z is equal to minus z bar, they given. I am going to write z bar is equal to minus z. This also correct. Both are correct only, but we use this one. Z bar is equal to minus z. So this I have proved. Z is real if only z is equal to z bar. If you want, I will prove now also. Z is equal to 5. Is pure, not pure, not you should not use purely real. It is real. What will be z bar? Z bar is also 5. Z conjugate of z is z bar. Conjugate of 5 is 5 only. So z is equal to z bar if z is real. I have shown what is my imaginary. So I have proved in previous iteration also for imaginary also. So no problem. So the last property is 10th property. Z bar is equal to z. 2 bar. For example, z is equal to 4 plus 3a. What will be z bar? 4 minus 3a. Once again the bar z bar. Once again bar may conjugate 4 plus 3a. Z bar is equal to 4 plus 3a is nothing but z. That's all. Z bar is nothing but z. So this is all the 10 properties we have proved. Students, the main thing, you need to memorize all these complex conjugates properties. Otherwise you can't able to do the exercise 2.4. This exercise 2.4 complex conjugate properties will be useful in exercise 2.5 also. So don't lose this. You need to memorize all the complex conjugate. The main thing I need to show you is nothing but you need to memorize this one. Real part of z is equal to z plus z bar by 2. Imaginary part of z is equal to z minus z bar divided by 2y. The other important one, very important one is 8 and 9. Think one thing. Z is real, z equals z bar. Keep this mind. Z is real, z equals z bar. Z is imaginary, z bar is equal to minus z. You should not forget this. 8 and 9 is very important. 8 and 9. Without 8 and 9, we can't do we can't do 3 to 4 sums in our exercise. Z is real, Z is equal to Z bar. Z is imaginary, Z bar is equal to minus Z. Write all these properties in our classwork also. Within this, we have finished our introduction in exercise 2.4. Thank you. Exercise 2.4, the first sum. We have detailedly saw the introduction part for exercise 2.4. Now, we entering the exercise 2.4. First sum, write the following Cartesian. You can say it is in Cartesian or rectangular form. Both are same, Cartesian or rectangular form. Cartesian form or rectangular form. What is the first subdivision? 5 plus 9i plus 2 minus 4i, the whole bar. How we can do? Nothing but this is real and real. 5 plus 2 is 7. Imaginary, 9 minus 4 is nothing but 5i. Still that is bar is present, put bar. So now we will remove the bar, conjugate. 7 plus 5i, can write as 7 minus 5i. So it is the easiest one. We can do in another method also, but this is the one the easiest one. So I am doing this in the method. 7 minus 5i. So next is second subdivision. The second subdivision is 10 minus 5i divided by 6 plus 2y. So I forgot one thing. This is the Cartesian form or rectangular. This is the Cartesian or rectangular form because real, after real, imaginary. I have taught you in previous exercise also. First you need to write real and then you write to imaginary. This is a proper rectangular form or proper Cartesian form. Real and imaginary, that's all. So they given this sum 10 minus 5i divided by 6 plus 2y. The above one is also a complex number and below one is also a complex number. I already told the complex number should not present in denominator, so I want to make a conjugate. So solution 10 minus 5i divided by 6 plus 2y. How I can write? 10 minus 5i divided by 6 plus 2y. Conjugate 6 minus 2y divided by 6 minus 2y. Conjugate is equal to, so you need to multiply. 10 6 are 60. 10 2s are minus 20i. 5 6 are minus 60i because, sorry, not 5 6 are 30. Sorry students, 5 6 are 30 minus 30i. Minus into minus plus 5 2s are 10. I into y, I square. What is I square value? Minus 1. I have told no. 6 plus 2y, 6 minus 2y. Listen carefully. 6 plus 2y, 6 minus 2y. Conjugate of 6 plus 2y is 6 minus 2y. I written one formula. A plus ib, a minus ib. Conjugate of a plus ib is a minus ib. The formula is a square plus b square. You should not write I. This is a, this is b. A square plus b square. The same. What will be a here? 6. What will be b here? 2. A square plus b square. A is nothing but 6. B is nothing but 2. So I will write here. A square, 6 square plus b square, 2 square. So 60. 10 into minus 1, minus 10. 60 minus 10 is 50. Minus 20 minus 30 is minus 50i. 6 square is 36. 2 square is 4. 36 plus 4 is nothing but 40. Overall common is, what is common here? In spite of writing common, I will put here 50 divided by 40 minus 50i divided by 40. 0 0 cancel, 5 by 4. This is real. 0 0 cancel, 5 by 4. This is imaginary. You can write in this format, or you can take 1 by 4 outside. 4 outside, instead of taking 1 by 4, 5 by 4, 5 by 4. I can take 5 by 4 outside, 5 by 4 outside, 1 minus I. This is also correct form. But this is our textbook answer. But this is real, this is imaginary. 5 by 4 is a real number, minus 5 by 4 is imaginary number. You can write in this format also. 3i bar plus 1 divided by 2 minus I. So this is a complex number. 1 is also a complex number. 1 is also a complex number. Divided by 2 minus I is also a complex number. So what I can do? Solution 3i bar plus 1 divided by 2 minus I 2 complex conjugate 2 plus I divided by 2 plus I. So how I can write 3I bar plus 1 into 2 plus I nothing but 2 plus I divided by A minus the same 2 minus I conjugate is 2 plus I. Here A is 2. I will write formula here. A plus IB, A minus IB is nothing but A square plus B square. What is A here? 2. What is B here? I coefficient is 1. A is 2, B is 1. A is 2 and B is 1. So 2 square plus B is 1, no, 1 square. So 3I bar is present. I can write as minus 3I. This plus 3I bar, I can write minus 3I. So 2 plus I, 2 square is 4, 4 plus 1 is 5. Now cross multiply. What comes? 5 3s are minus 15I plus 2 plus I divide by 5. So what is the answer is going to be? 2 is real. Minus 15I plus I is nothing but minus 14I divided by 5. First you can write in division form. 2 by 5 minus 14 by 5 I. This is real, this is imaginary. Otherwise you can write 1 by 5 outside, 2 minus 14I, but this is a correct form, rectangular form, real and imaginary. Second sum, if z is equal to x plus iy, find Cartesian form of real part of 1 by z. I need to find the real part of 1 by z. They given z. Solution, they given z. Z is equal to x plus iy. So apply here. Real part of 1 by, what is z? X plus iy. I have told in previous, complex number should not present in the denominator. This is also a complex, 1 is also a complex number, x plus y is a complex number. So real part of 1 divided by x plus I, nothing but conjugate, x minus iy divided by x minus iy. So real part of 1 into x minus iy is nothing but x minus iy. I have now also written a formula, a plus ib, a minus ib. Here a is x, b is y. So x square plus y square. Now separate real part of separate x divided by x square plus y square minus y iy divided by x square plus y square. So my question is real part of this bracket. Which one is real part? This is real part. So the final answer is going to be real part. What is the real part? Real part is nothing but x divided by x square plus y square. This is a real part. Suppose if they are going to ask imaginary part, minus y divided by x square plus y square. It is imaginary part. That's all. They are asking real part, x divided by x square plus y square. If imaginary part, minus y divided by x square plus y square is our answer. So within this we are finishing this, the first subdivision. Real part of I z bar. Solution, you know z is equal to x plus iy is given, apply here. Real part of I. If z is x plus iy, what will be z bar? X minus iy. If z is x plus iy is given, z bar, what is z bar? X minus iy. So I into x minus iy. You can even understand things. So z bar is x minus iy. Therefore real part of multiply I into x is ix minus I into I square is minus 1, it becomes plus y. So which one is real part? First arrange it properly. Real part of y plus ix. Which is real part? Y is real, this is imaginary. So final answer is going to be our y. How easy the sum is? Next, the third one is third subdivision. The final sum in this second sum, third subdivision. Imaginary part of 3z plus 4z bar minus 4i. Solution, we know the given z is equal to x plus iy. We know z bar is nothing but x minus iy. Apply here. Imaginary part of 3 into x plus iy z no plus 4 into x minus iy minus 4i, close the whole bracket. So imaginary part of 3 into x is 3x plus 3iy, nothing but 3yi. You can write 3iy, no problem. 4 into x is 4x minus 4 4yi, 4yi minus 4i. So separate real and imaginary part. Separate real. Which are real? 3x plus 4x is nothing but 7x. There is any real present here? No. Remaining all imaginary. Before writing imaginary, 3yi minus 4yi. How we can write as minus yi. Remaining minus 4i. So now separate real imaginary. Imagine nothing but real is something 7x minus I can be taken outside, otherwise plus I taken outside becomes minus y minus 4, close the bracket. Listen very carefully in this sum. In this step, 7x is real. I am going to take I alone outside. In this I am going to take I alone outside. I moved outside. So minus y minus 4, minus y minus 4. So now write imaginary part. This is real, this is imaginary, nothing but minus y minus 4 is the imaginary. So this is the easiest sum. Within this we are finishing the second sum. Next we move towards the third sum. Third sum, z1 is equal to 2 minus I and z2 is equal to minus 4 plus 3i. To find inverse of z1 and z2 and z1 by z2. So first listen carefully. They given z1 values, they given z2 values. First find inverse of z1 and z2. So solution, first write inverse of z1 and z2 is nothing but z1 z2 whole power minus 1. That's all. z1 into z2 whole power of minus 1. Next inverse of z1 by z2 is z1 divided by z2 whole power minus 1. This is the inverse. This is the inverse. So how I can write this inverse? This inverse can be in either formula. A power minus m I can write as 1 divided by a power m. The same format. 1 divided by z1 into z2. 1 divided by z1 divided by z2. In this z2 comes upon z2 divided by z1. So this power minus 1 can put in the denominator. 1 divided by z1 z2. Power minus 1 divided by z1 by z2. Z2 by z1. So this one we need to find. First I need to find 1 divided by z1 and z2. Other I need to find z2 by z1. Z2 divided by z1. So how I can able to find? So 1 divided by z1 and z2 is nothing but 1 divided by, what is z1 here? 2 minus I. What is z2 here? Minus 4 plus 3i. So 1 divided by 2 minus I. Multiply 2 into minus 4 is minus 8. 2 3s are 6i. Minus into minus plus I into 4, 4i. Minus into plus minus 3. I into y, I square. I square value is minus 1. So how I can write this answer? 1 divided by, this is minus into minus plus minus 8 plus 3. Minus 8 plus 3 is minus 5. Next, plus 6 plus 4i is nothing but plus 10i. Plus 10i. So I have written this. So if I want, I can take common here and do, but problem is once again I need to do the conjugate here. Why? Once again I need to conjugate because this is complex number, this is another complex number, this is not in proper rectangular form. I need to make a conjugate. So I can conjugate 1 divided by minus 5 plus 10i. I can do minus 5 minus 10i divided by minus 5 minus 10i. Because I need to change conjugate only for I. Minus 5 plus 10i is minus 10i and minus 10i. So 1 into minus 5 is minus 5 minus 10i. We can write as it is. So you know this is A, this is B. A square plus B square. A square minus 5 the whole square, 25, plus B square, 10 square is nothing but 100. 10 square is nothing but 100. So now what you can do? What is common here? 5 is common. Take 5 outside. Become minus 1 minus 2y divided by 125. And nothing but 125. Now I can make a cancellation. 5 and 1 times 25 times. So 1 divided by 25 minus 1 minus 2y. Otherwise I can write as minus 1 divided by 25 and minus 2 25 divided by I. This is also the correct answer. So this is the inverse of z1 and z2. Therefore, inverse of Z1 Z2 is answer. You can write final answer. Inverse of Z1 Z2 is 1 by 25 minus 1 minus 2y. Otherwise, minus 1 by 25 minus 1 by 25 minus 2 by 25i. Final one is inverse of Z1 divided by Z2 whole power inverse. We write as finally Z2 by Z1. This is inverse of. The Z2 is minus 4 plus 3i. Sorry, Z1. And Z1 is 2 minus i. So I need to conjugate minus 4 plus 3i divided by 2 minus i, conjugate 2 plus i divided by 2 plus I. You can do multiplication. Minus 4 into 2 is minus 8. Minus 4 into I is minus 4i. 3 2s are 6i. 3 into 1, 3. I into I square is minus 1. A minus I, A plus IB, A minus IB. A is 2 here. 2 square is 4. I coefficient is 1. 1 square is 1. So the answer is going to be, what is the answer? Minus 8 minus 3. Nothing but minus 11. Minus 4i plus 6i. The answer which gives us plus 2i. Answer is 11. 4 plus 1 is nothing but 5. The final answer is going to be 1 by 5 minus 11 plus 2i, or minus 11 by 5 plus 2 by 5i. Therefore, inverse of Z1 by Z2 is 1 by 5 minus 11 plus 2i, or minus 11 by 5 plus 2 by 5i. This is the required answer for this sum. Within this we are finishing the third sum also.